This is a hands-on class, so open the lab guide and write manifests alongside me. Last class you got fast with kube control using imperative commands and 8012v, telling the cluster to do this right now. That is perfect for learning and quick tasks. But real Kubernetes work, the kind you do in production and the kind the exams test, is declarative. Instead of commanding each step, you write down the state you want the cluster to be in, hand that description to Kubernetes, and let the cluster figure out how to make it true and A212 and keep it true. That description is a YAML manifest, and understanding its structure is one of the most important skills in all of Kubernetes, because every single object you will ever create follows the exact same shape. Today, we will learn that shape and A212, the 4 fields every manifest has, and A212, and the object model underneath it, the deep idea of desired state versus actual state, and how apply and reconciliation bring the two together. Get this right, and the rest of Kubernetes becomes a matter of learning new kinds of objects that all work the same way. Let us write some YAML. Here is our path for today. First, why declarative YAML is the real way to work. Second, the 4 fields in every manifest. Third, API version and kind. Fourth, metadata. Fifth, spec versus status. And sixth, apply and reconciliation. Let us dive in. Let us start with the shift from imperative to declarative because it changes how you think about a cluster. Imperatively, you script the steps, create this, then scale that, then update the other. Declaratively, you do something quite different, and A1212. You write a file that simply describes the end state you want. A2020. I want 3 copies of this application running, exposed on this port. And A2021. You do not say how to get there. You say what an A2020, there an A2020, looks like, and Kubernetes works out the how, and makes reality match. Why is that better? Because the file becomes the source of truth. You can put it in version control, so every change is tracked and reviewable, just like code. You can apply it 100 times and get the same result. A colleague can read it to understand exactly what should be running. And if the cluster drifts, you reapply the file, and it snaps back. The description is durable. The steps to achieve it are Kubernetes and IKA problem, not yours. This is the heart of what people mean by infrastructure as code, and it is why every serious Kubernetes shop works this way. Imperative commands are a screwdriver for quick jobs. Declarative YAML is the blueprint for the building. Both have their place, but the blueprint is what you keep, share, and rely on. So from here on, we write manifests. So the takeaway, declarative YAML describes the end state you want rather than the steps to reach it. And Kubernetes makes reality match, and A2112, giving you configuration that is version controlled, repeatable, reviewable, and self-healing, which is the essence of infrastructure as code. Here's the reassuring part. Every Kubernetes manifest, no matter how complex the object, has the same 4 top-level fields. Learn these once, and you can read any manifest. The first pair is API version and kind. Together they answer an A220. What type of object is this? An A220, an A220, is it a pod, a deployment, a service, and which version of the API defines it? This is the object N309's identity as a type. The third field is metadata. This answers N8020. Which specific object is this? N8021, N802012. Its name, the namespace it lives in, and the labels attached to it. If API version and kind say what kind of thing it is, metadata says which particular one. The fourth field is spec, and it is where the substance lives. Spec answers an N8200. What state do you want? An N8201, an N8201, the actual configuration, how many replicas, which container image, which ports, and so on. The spec is different for every kind of object, but it is always the field where the desired state is written. Type, identity, desired state, and 85 API version and kind, metadata, spec. 4 fields, every time. So the takeaway, every manifest shares the same 4 top-level fields, and A212, API version and kind name the object ND99 is type. Metadata identifies the specific object, and spec describes the desired state, and A12 all. So once you know this shape, you can read any Kubernetes object. Let us take those fields one at a time, starting with the pair that names the object and team-porting pies type. Kind is the straightforward one. It is the type of object you are describing. Pod deployment, service, config map. When you read a manifest, kind is the first thing you look at because it tells you what you are dealing with. It is the noun and A2112, the thing itself. API version is its partner, and it tells Kubernetes which API group and version defines that kind. Some objects live in the core group and have a simple version like v1. Others live in named groups like app/v1 for deployment. The reason this exists is that Kubernetes evolves an AT212. New versions of an object type can be introduced without breaking the old ones, and AT212. An API version pins exactly which definition you mean. In practice, you rarely have to memorize these. Kubecontrol Explain will tell you the correct API version for any kind, and generated manifest fill it in for you. But you must understand what the pair is doing. API version and kind together tell the cluster unambiguously exactly what type of object this YAML describes, and A122, which is the first thing the API server checks when you submit it. So the takeaway, kind is the type of object, and A212 pod, deployment, service, and A212 an API version says which API group and version defines that kind. Letting Kubernetes evolve object types safely, together they tell the cluster exactly what type of object your manifest describes. Next is metadata, which identifies the specific object, and 812, and hidden inside it is one of the most important concepts in Kubernetes. The obvious parts first, metadata holds the object and 39 piece name, which must be unique for that kind within its namespace, and the namespace itself, which is the logical partition the object lives in. Now my name plus namespace is how you and the cluster refer to this exact object, and A212, how kubecontrol finds it, how you delete it, how everything addresses it. But the part that matters most is labels. Labels are simple key value tags you attach to objects, and A212, things like app equals front end or environment equals production. On their own, they seem trivial, but they are the connective tissue of Kubernetes. Selectors use labels to answer questions like an A2020, which pods belong to this service, A2020 on, or an A2020, which pods does this deployment manage, and A2020 on. The wiring between objects is done through labels and selectors, not hard references. So metadata is doing double duty. Name and namespace give the object its identity, while labels give it membership, and A212, they let you group, select, and connect objects flexibly. When we get to services and deployments, you will see that this label and selector mechanism is how the whole system fits together. Get comfortable labeling things well. It pays off everywhere. So the takeaway, metadata carries the object and TT9, sesh name and namespace, and AT21 or for its identity for addressing it, and AT21 plus labels, the key value tags that selectors use to group and connect objects, which is the connective tissue wiring the whole system together. Now, the deepest idea in the entire object model, and the one that unlocks everything, spec versus status. Spec is the desired state. It is the part you write, and A2112.5 what you want to be true. A2020, I want 3 replicas of this image running. A2021, the spec is your intention, your declaration expressed in the manifest. When you edit a manifest, you are editing the spec. Status is the actual state. It is the part Kubernetes writes, and A2112, a live report of what is really happening right now. And AT2020, 2 replicas are running, 1 is still starting. AT21, you never write status. The cluster maintains it for you continuously to reflect reality. When you run kubecontrol describe, Much of what you read is the status. Here is why this two-part model is so powerful. Kubernetes constantly compares the spec to the status in 8112, what you want versus what exists in 8112, and works to close any gap between them. If you ask for 3 and only 2 are running, the difference is visible and the system acts to fix it. This gap closing is the engine of Kubernetes, and it rests entirely on separating an A200-200, what I want an A200-200, from an A200-200, what is an A200-200. You own the spec, the cluster owns the status, and the whole system exists to make the second match the first. So the takeaway, spec is the desired state you write, and 82 to a Havi, your intention, 82 Havi, and status is the actual state the cluster continuously reports. Kubernetes exists to compare the two and close the gap, which is the engine that makes the whole system self-driving. That gap closing has a name and a mechanism, and this is where declarative YAML comes alive. It starts with kube control apply. You take your manifest and AT-OTOL, your desired spec and AT-OTOL, and apply sends it to the cluster. Unlike create, which fails if the object already exists, apply intelligently creates it if it is new or updates it if it already exists, merging your changes. That is why apply is the command you use for declarative work. You can run it over and over as your manifest evolves. What happens next is that the API server stores your desired state. Your spec is now recorded as the source of truth. In the cluster NT9 database, the cluster now knows what you want and 8012, but wanting is not yet having. Something has to make it real. That something is reconciliation carried out by controllers. A controller is a component that watches its objects, compares desired state to actual state, and takes action to close the gap, and A212 then keeps watching forever. If a pod dies, the controller notices the gap and creates a replacement. If you change the spec to 4 replicas, the controller notices and adds one. This continuous loop and 8080 SAN12, observe, compare, act, and 80 SAN2 is reconciliation, and it is why Kubernetes is self-healing. You declare the state once, and controllers hold reality to it indefinitely. So the takeaway, kube control apply, sends your manifest and the API server stores the desired spec. Then controllers reconcile and A202 halve, continuously observing, comparing desired to actual, and acting to close the gap, and AT24, which is why a declared state is not just said once but held true forever, making Kubernetes self-healing. Before the habits, let me hand you 3 commands that make writing YAML fast, so you are not typing manifest from memory. First, generate a starter manifest instead of writing from scratch. Take an imperative command, an A2112, the kind you learned last class, an A2112, and add dry run equals client with output as YAML. Kubernetes prints the full manifest it would have created without creating anything. You save that to a file and edit it. This is the fastest way to get a correct skeleton, and it is a lifesaver in the exam. Second, when you do not know a field, ask kube control explain. It documents every field of every object right in your terminal and AT200. What goes under spec, what each setting means, which are required. Instead of guessing or searching the web, you explain your way down into the object and read the definitions directly from the cluster. And third, read a live object back as YAML with get, the object, and output as YAML. This shows you the full manifest of something already running an AT100 tool, including the status the cluster filled in an AT100 tool, which is invaluable both for learning the real shape of objects and for debugging what is actually deployed versus what you thought you deployed. Generate, explain, read back, 3 commands that turn YAML from a chore into a fast, confident workflow. So the takeaway, 3 commands make manifest work fast, and A2.1, dry run with output YAML, generates a correct starter, kube control explain documents any field in your terminal, and get with output YAML reads a live object back an A212, so you never write manifests blindly from memory. Let us close with the habits that make declarative Kubernetes reliable rather than a source of surprises. First, keep your manifests in version control. This is the whole payoff of being declarative and AT112. If your desired state lives in a Git repository, your cluster becomes reproducible, your changes become reviewable, and you can roll back a bad change by reverting a commit. A cluster configured by manifests in version control is a cluster you can trust and rebuild. One configured by ad hoc commands is one you fear to touch. Second, use apply, not create, for anything you intend to maintain. Apply handles both creation and updates cleanly, so the same command works whether the object is new or being changed. Mixing in imperative create and edit muddies the picture of what your true desired state is. Apply keeps the manifest as the single source of truth. And third, when reality does not match what you declared, read the status and the events. Describe the object and look at its status and its recent events and A212. They almost always tell you why the gap is not closing. An image that will not pull, a resource limit hit, a scheduling problem. The object model gives you this for free. Use it. Version control your manifests, apply rather than create, and read status when things drift. 3 habits that make declarative Kubernetes calm and predictable. So the takeaway, work declaratively with discipline and AT212. Keep manifests in version control so the cluster is reproducible and reversible. Prefer apply over create so the manifest stays the single source of truth. And read status and events whenever reality does not match your spec. Let us gather the whole class in one breath. Declarative YAML describes the state you want, and Kubernetes makes it true and AT212 repeatable and version controlled. Every manifest has the same 4 fields: apiVersion, kind, metadata, and spec. apiVersion and kind together say exactly what type of object it is. Metadata gives it a name, a namespace, and labels that identify and group it. Spec is the desired state you write. Status is the actual state the cluster reports. And apply declares the state, while controllers reconcile and A212, driving reality to match forever. Next class, an AT81 pods up close, the smallest deployable unit in Kubernetes. One idea at a time. That is the YAML manifest.